Have you ever wondered how a control room operator knows the exact liquid level inside a sealed tank without ever looking at it? By the end of this video, you will understand how a level transmitter works, what signals it sends, and why it is critical to safe plant operation. A level transmitter is a field instrument that continuously measures the liquid level inside a vessel, tank, or drum and converts that measurement into a 4 to 20 milliamp signal that your DCS or PLC can read and act on. Level transmitters are installed everywhere in industrial plants. You find them on storage tanks measuring fuel oil or crude, on process vessels measuring reactor level, on boilers monitoring drum level, and on separators in oil and gas facilities. Without accurate level measurement, a tank can overflow and create a spill or run dry and damage a pump. In many applications, the level transmitter signal feeds directly into a level controller that opens or closes a control valve to maintain a safe level set point. There are several technologies used to measure level, each suited to different applications. Hydrostatic level measurement uses pressure to infer level, the most common type in refineries and petrochemical plants. Ultrasonic transmitters bounce a sound wave off the liquid surface and measure the echo time. Radar transmitters do the same using microwave signals, making them excellent for vapor-filled or turbulent vessels. Guided wave radar sends the signal down a probe touching the liquid. Capacitance and displacer types are also used for specific process conditions. This video focuses on the most fundamental type, the hydrostatic pressure method. The hydrostatic level principle is simple. Liquid has weight, and that weight creates pressure on the bottom of the vessel. The taller the column of liquid, the greater the pressure. The transmitter measures this pressure at the bottom of the tank and converts it to a level reading using the formula. Pressure equals density multiplied by gravitational acceleration multiplied by height. So if the liquid density and the vessel geometry are known, the transmitter can calculate the exact level from the measured pressure. In practice, the transmitter is calibrated for the specific tank and liquid, so the DCS receives the level directly in meters or percentage. Like most process transmitters, a hydrostatic level transmitter outputs a 4 to 20 milliamp signal proportional to the measured level. When the tank is at the lower range value, which is often the minimum measurable level, the transmitter outputs 4 milliamps. At the upper range value, the full tank level, it outputs 20 milliamps. The 4 milliamp live zero is critical. It means the loop is powered and functioning. If the cable breaks or the transmitter fails, the current drops to zero, which the DCS immediately recognizes as a fault condition, not a valid zero level reading. A scaling example: for a tank range 0 to 5 meters, a 12 milliamp signal represents exactly 2.5 meters of level. The formula is level equals the signal minus 4 divided by 16 multiplied by the span. The 4 to 20 milliamp signal travels through shielded instrument cable from the transmitter in the field to the marshalling cabinet, through the junction boxes and terminal blocks, and into the DCS analog input card. Inside the DCS, the card converts the milliamp signal to a digital value and passes it to the controller. The operator sees the tank level as a percentage or in engineering units on the HMI screen. A quality good indicator confirms the DCS is receiving a valid live measurement. This is a conventional hardwired DCS signal path. Some modern plants use field bus or wireless transmitters, but the fundamental measurement and conversion principles remain the same. Quick check before we continue. A level transmitter is range 0 to 10 meters, and the signal reads 12 milliamps. What is the actual liquid level? Think about it. The answer: 12 minus 4 equals 8. Divide 8 by 16 to get 0.5. Multiply by the span of 10 meters. The level is 5 meters, exactly 50% of the tank. Every level transmitter has two key calibration parameters: the lower range value, or LRV, and the upper range value, or URV. The LRV is the process level at which the transmitter should output exactly 4 milliamps. The URV is the level at which it should output exactly 20 milliamps. When you calibrate the transmitter, you apply a known reference pressure corresponding to the LRV and zero the output, then apply the pressure for URV and adjust the span. If the transmitter drifts over time, the DCS will show a level that does not match the sight gauge, a clear sign that recalibration is needed. On HART-enabled transmitters, you can adjust the LRV and URV digitally using a HART communicator without disconnecting the instrument. In the field, level transmitters fail in recognizable patterns. A plugged impulse line is one of the most common problems. When the line connecting the transmitter to the vessel becomes blocked with sediment or solidified product, the transmitter reads a frozen or false value. A ruptured disc or isolation valve left closed can also produce a stuck reading. If the transmitter reads full or empty when the process is stable, check the impulse lines first. Condensate buildup in the high side line on a differential pressure level measurement can shift the zero and cause a high-level error. Regular blowdown of impulse lines and density corrections for liquid changes are essential maintenance practices. One technology worth understanding is the displacer level transmitter. Inside the instrument housing, a solid float called a displacer hangs on a torque tube connected to the transmitter mechanism. As the liquid level rises around the displacer, buoyancy force reduces the apparent weight on the torque tube. The transmitter detects this change in torque and converts it to a level measurement. The genius of this design is that the displacer never floats. It always remains heavier than the liquid, so the measurement is based on buoyancy change, not displacement. Displacer transmitters are excellent for high pressure, high temperature, and viscous liquid applications where pressure-based measurement would be unreliable. Here is what you now know about level transmitters. A level transmitter continuously measures liquid level and outputs a 4 to 20 milliamp signal proportional to level. The hydrostatic type measures the pressure created by the liquid column and converts it to a level using the density-gravity-height relationship. The 4 milliamp live zero keeps the loop powered and distinguishes a real zero level from a cable fault. LRV and URV define the calibrated measurement range. Common faults include plugged impulse lines, closed isolation valves, and condensate errors. Level measurement directly enables safe operation. It prevents tank overflow, pump cavitation, and process upsets that could have safety and environmental consequences. Thanks for watching. If this video helped you understand level transmitters, please subscribe for more videos on instrumentation, process control, and OT cybersecurity. Every week, we cover topics that matter to instrument technicians, control engineers, and OT security professionals working in real industrial plants.